Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izzat bin Muhammad Nuruddin. So I am from RY21. So today I will do demonstration for lab 6 control system design, Ziegler Nichols method. So we proceed. So this lab we need to use Ziegler method, Ziegler Nichols method to find the value of the PID to solve the problem for the transfer function using MATLAB. So in this lab we will see the rise time, overshoot, settling time and steady state error, the difference between the PI and PID, and the original transfer function without the Ziegler Nichols method. So for this lab we use this equation, and this one is a controller for the K. And before we do the this experiment, we need to do the mathematical modeling first, mathematical calculation first. And okay, for the procedure 3.1, as we can see for the graph here, we get for the no Nichols Ziegler method, so just the for the transfer function only. So we get good but we don't get the desired output, which our desired output is 1. So this is the PID value for the Ziegler Nichols. So we do the calculation. So we get the transfer function, we include the K function, and then we do the mathematical, and we get this s power of 3 plus 6 s power of 2 plus 11 s plus 6 plus 6k. So after that we substitute the s with the j omega. So and then we differentiate the part with the imaginary and the real. After that we do calculation for PCR, and then we get the value for the K. So K is 10, j omega is 3.32, and the PCR is 1.89. And then we do the Nichols Ziegler method using the formula for the method. So we just need to key in the value we get here, value of K, value of PCR, and for the omega we can find the PCR. So we get the value. After that we need to do the mathematical MATLAB. So for the MATLAB coding here, I just combine all of the PID controller and the without PID. So I will run it. So we get this kind of transfer function response. So for first one, this one is transfer function without the PID. So for the steady state, rise time is good, but it doesn't get our desired value. So for P controller, which this one, the red one, I think. So the red one. So as we can see, the red one have rise time and the steady state is good, but it doesn't get our desired output. So for the PI controller, which is this one, the highest rise time and overshoot, and then as you can see, the oscillation is very high, but at the end it get the at the desired value as at the set point though. And lastly, combine all the PID for this green one. So you can see for the green one, we got good rise time and overshoot and a little bit of oscillation, and get steady state error here. So we can see the value here, but okay, this one. So overshoot will be 40% at the time 1.16 second. Settling time here, this one is 4.7, 4.8, and steady state for the this one is equal to final value 1, 0.8 and 0.5. So for the PID only for the PID and the PI should get the value, but the PI does not have good steady state error. So this is the coding for the MATLAB, and from this graph we can get this value using this function. So we just need to pin out the point. So I guess that's all for demonstration for this Leipzig. Let's just input the value of KP, KI and KD here. This function here is for the no transfer function, no Ziegler's method, and then we just include the Ziegler's method here, here and here. Put the value KP, KI and KD, so we get the graph. Okay, I think that's all for my presentation. Thank you for listening. Thank you.